Up on the workbench, I have a Panasonic inverter type microwave oven. Is dead. I'm not going to hold much hope for this unless it's one of the interlock switches that's kicked out the fuse. A lot of times the inverters fail on these and they're not economical to repair because the inverters themselves are really quite expensive and the microwaves themselves are really quite cheap. So let's take a look and see. Maybe we'll get lucky and we've just got some switches that are bad on this one. To say that these inverter units are not my favorite units is an understatement. I've never liked the inverter design ever since I had to work on the bloody things back in the 90s when they first came out. And they may be a little more reliable now, but the first series out were just nothing but trouble. Okay, we have an open fuse on this unit. It says special fuse. But why is the fuse popped? It could be the inverter has failed, it could be one of the safety switches has failed, or it could be the magnetron that's causing problems on this unit. We'll check the switches first. So here are two scenarios drawn out here to scale. When the door is in the open position, here's our fuse and our thermal cutout. Our low voltage transformer is always powered up as long as the fuse isn't blown and the thermal cutout isn't open. And that's providing power to the timer circuit. When the door is open, your primary interlock switch opens, and the secondary or the shorting switch, the failsafe as it's sometimes called, is shorted. That way, if this switch were to fail to open and this one's shorted, it would put a dead short on and cause the fuse to blow. This is how, and then of course over here is where your power to your inverter or your high voltage transformer would be. Going to, obviously through the timing control circuit, they go to a relay to control it, but that's where your magnetron and your power supply and stuff would be on this side. That way, when the door is closed, and here's the scenario when the door is in the closed position, now we've got a complete primary interlock switch closed. Our AC 120 volts can now reach the power inverter, and the short switch is open. So, of course, if that short switch were to close while the primary switch is closed, it's going to blow the fuse. So this is what you always have to check, these switches, no matter what. When a microwave oven comes in with blown fuse, you always have to check those switches before you change that fuse. So the switches are located right down here. Actually, there's two sets of switches. There's one here, and there's two more switches down here. And how these switches are configured, it's configured as a one switch that is open when you open the door, the main switch will open. That cuts off power to the unit. But there's a fail-safe switch on there. If the door is open and the primary interlock fails to open power, the secondary interlock switch will provide a dead short across the line to blow the fuse. So the first thing we're going to check is the switches to see whether any of the switches have failed. Now when these switches fail, they typically blow themselves up in the process. So that's the primary switch there. The primary switch we can test with a meter. It should be open until you press the button down. So if I put my broken probe on there, okay, so that switch appears to be working. So let's take out the secondary switches now and see whether the secondary switches have got a problem. Now one of these two switches, the front one here that's got the orange and white wires, this one here, all it is used for, it's to tell the timer to stop counting down when the door is open. It's the back switch that's the safety switch. So we'll take the front switch off here first. Easier said than done. So this switch here won't be the problem, because all this one does is shut off the countdown of the timer. The switch at the back here, this is the safety switch. So this is the switch that will short if the other switch fails to open. Of course, sometimes these switches just short because people slam doors. And this switch will normally be shorted when it's open. This is a normally closed switch, I believe, which it is. So that's normal. Okay, if we measure this one, okay, I've got continuity, but when I press the switch in, the beep should stop, which it does. So that tells me that the switches are not at fault on this unit. So we either have a bad magnetron or we have a bad inverter board. There's only one way to find out. We're going to plug this unit in. I'm going to plug it into my light bulb source, my current source, to limit the current to this thing to 1 amp. And I'm just going to see whether it lights up and whether it draws any power and whether we can produce any high voltage. So let's put the switches back in place. Okay, that one's in place. Can't believe the amount of plastic that's on these things now. It's disgusting. Not like the good old days where, you know, they had some metal in these things. Okay, that switch is back in. Okay, so this thing's ready to power up. I do have a ground wire in place so my chassis is grounded. And I'll put some power to it. And the unit is now going to light up, I believe. Yeah, it's lighting up. I've got the magnetron disconnected here. The high voltage leads are disconnected, so if this thing draws a whole whack of current, then we got a problem with the inverter. If it doesn't draw a whole whack of current, then chances are the magnetron is where the problem is on this thing. So I'm just going to put this thing on for like 5 seconds if I can figure out how to do it. Yeah, 5 seconds. Okay, and start. Okay. It didn't blow anything. Going to connect one lead of the magnetron this time. We'll try it again and see if this thing does anything. Well, it didn't blow. As you can see, I'm not really running a fuse on this thing, but I am limiting the input power to 100 watts from the from my current limiter. Now again, I'm not going to touch this lead without using some type of a tool to isolate. Let's just see whether this thing will try to fire up the magnetron. Let's try and do something. I can see my light is flickering on and off there. I'm just going to try and see if I can. I'm going to set it for a little longer. I'm going to put some water in it and see whether we get any type of heat. It might be just that the fuse popped on this, right? And okay, I'm going to try running it off direct power now without going through the current limiter. I don't have a fuse in this thing, so obviously I just want to test it. It is plugged into my 15 amp power bar, so if it draws too much power, it's going to trip the breaker that's in my power bar anyway. But we'll just run this thing here for, see if I can run it for a few minutes, or a minute anyway, and see whether all hell breaks loose or whether it's going to heat, because it may have been just that the fuse got weak. And it sounds like the magnetron's coming on. So we may have just had a fuse that failed due to a power surge or something. But again, whenever you have a fuse that goes bad on a microwave, you always have to check for the fuses, or not, sorry, you always have to check for the interlock switches every time, because if those interlock switches fail, they will weld themselves shut, so they won't work. Okay, we just tripped the breaker here. So that's probably because I don't think it's because that the microwave is drawing too much juice. I think it's because I got too many things running here. I had a couple plasma TVs going, and my monitor and everything was going here as well. It is heating. Let's turn the power back on and try this again without having all my bench stuff going, because I had my display monitor for my camera was running. I had two plasma TVs running at the same time. So I just think we drew a little bit too much power. Let me reset this thing. I just scared the crap out of the cats. I'm going to shut off the bench lights, because this thing is going to draw pretty close to 15 amps when it runs. So I'm going to make sure that everything's turned off except this microwave. And we'll try it one more time. Okay. Let's try this again. So I've set it to 1 minute. I've shut off everything else in the garage that was drawing power, because I probably had 500 or 600 watts loaded onto that circuit, maybe more. I had two plasma TVs running, and they're going to draw, under test of course, they're going to draw 300-400 watts a piece. My bench monitor, my LCD monitor, I think it draws about 400 watts. I had a 65 watt light and a 42 watt light running on the bench, and then I plugged in a 1200 watt microwave. You think that might be why I tripped the breaker? I think so. I think we're just looking at, see, this is 1200 watts, this thing. This is a high power unit. I think we're just looking at a fuse that got tired and due to stress failed. 5, 4, 3, 2, 1. We'll see if this water is hot. Oh yeah, I can't. The water's hot. If I put it in there for another minute, it'll be boiling. So let's try it. We'll put it on for another minute. There we go. As you can see, the water is steaming. And I would not put my finger in there. There's steam coming off the water in 2 minutes. So this microwave works. All that was wrong with this microwave is the fuse blew. The fuse probably just got weak. It's not blown like to smithereens, but sometimes these fuses just after a period of time get weak. But if you're working on a microwave oven, it is mandatory that even the plugs get warm on these things. My jumper's warm. You gotta get a new fuse for that thing the right size. When you're working on any microwave oven, no matter what, and you have a blown fuse, you can't just change the fuse and think that everything's cool, because the fuse sometimes can blow. In this case, it just did on its own, but a lot of times it's caused by the primary interlock switch failing to open when you open the door. And if that was the case, then the secondary interlock, sometimes called the short switch, which I'll show you in a little diagram, but what it's designed to do is it puts a dead short across the line on the input to the inverter. Therefore, if the primary switch sticks, the secondary switch shorts, it'll blow the fuse. That's what its job is. Its job is to blow that fuse, to make sure that this thing is dead and it could never start up, because if it was not there and the primary switch were to fail and you were able to start the thing up with the door open. So they have the primary and secondary interlocks. They must be checked. The rule was if a microwave came in for service and the fuse was blown, we had to change the switches no matter what. That used to be the rule, that you had to change the switches. But that's not so much the case anymore, because it was figured out that if these switches do short and you put a dead short across them, they're going to weld themselves together and they are not going to work. So if you take the switch out and you can toggle it back and forth and it goes open or closed, it's not shorted. Quite often what will happen is, and this will blow the switches, people will slam the doors. I don't have the power on it now, but they'll slam the door hard. You know, you'll get someone who's upset about something, they'll slam the microwave door, and what'll happen is they'll bounce the switch contacts, and one will short before the other one, or one will close before the other one opens, and you'll end up with welded contacts and a blown fuse. Very common problem. In this case, that's not what happened. The fuse just got weak and popped there. So, hope you enjoyed that one. We'll catch you in the next video. Can't put the fuse in today as I don't have one, but I'll get one and get that going and get it back to its owner. We'll catch you later.